Good morning all of you. We are discussing about the electrolytic cells. Is indirectly nothing but electrolysis. So what is the meaning of electrolytic cells? Already yesterday given definition: a cell in which what change is going on? Electrical energy will be changes into which one? Chemical energy. Just through any electrolytic solution, you are sending current, definitely chemical reactions will be going on, means new products is forming. The whole device you are calling as electrolytic cells are nothing but electrolysis. Some points you have to remember here. Under electrolysis, the getting products is depending upon some factors like nature of the electrodes. That's what I have read here. So, formation of the products in electrolysis. Formation of the products in electrolysis depends upon the nature of the electrodes. Nature of electrodes. And can you tell some other? It is also depending upon the nature of the electrolyte. Nature of electrolyte. And also concentration of the electrolyte. Concentrations of the electrolyte. And also temperatures. These all things will influence the formation of the products under electrolysis. Mainly I will explain 4 different electrolysis process is very important for competitive point of view. Under this first one I am explaining electrolysis of molten NaCl. Molten NaCl. Already I told yesterday, molten NaCl means you are taking pure NaCl, means solid NaCl you are taking and keep on heating without adding any solvent. So what happening? NaCl goes in liquid medium, that is only we are calling as molten NaCl. What is the situation in molten NaCl? Na plus particles and Cl minus particles are free to move, that they will pass or they will carry the energy throughout the chemical reaction itself. So first of all, I am taking molten NaCl, I am taking here. So I am using some inert electrodes I am using like platinum or some other I am using. Positive terminal of the battery, it is connected to the negative terminal of the battery. The rod carries positive charge, the rod carries negative charge, it is calling as a anode. The negatively charged rod is calling as a cathode. And in the galvanic cell, that is totally different from this electrolysis. In the galvanic or voltaic cell, negative cell means negative charge means anode and positive charge means cathode. So, but here this is totally different from that one. In this, what ions will be present here? Na plus and Cl minus only present because no solvent. Okay, now what happening anybody? These Na plus particles moves towards negative or positive one? Moves towards negative, and the Cl minus moves towards positive charge. Means at anode, what happening? Generally, anode means which charge? Positively charged rod. So generally at anode, what phenomena is going on? Oxidation will be going on. Okay, now which particle moving towards anode or this side? Yes, Cl minus. 2 Cl minus particles is becoming like Cl2 gas plus 2 electron. Anyway, loss of electrons is calling as oxidation. So under molten NaCl electrolysis at anode, which gas is liberating? Chlorine gas. But at cathode, so you know very well cathode means is nothing but negatively charged rod will attract a positively charged particle from the medium, and at cathode always what phenomena is going on? Reduction will be going on. Which particle going towards cathode? Na plus. Those Na plus will receive the electrons from the battery. So then what happening? Na plus plus electron is becoming like Na neutralized nothing but solid. Means on this cathode rod, what happening? Na sodium layer formation will be happening. From solution, whatever sodium particles is undergoing sticking or forming a new layer on the cathode according to this reaction. All of it clear. So finally we will ask under electrolysis of molten NaCl at anode, what is producing? Cl2. At cathode, what is happening? So Na sodium formation will be going on. And now I want to tell one more electrolysis is nothing but electrolysis of aqueous NaCl. aqueous NaCl. Okay, what is the meaning of aqueous NaCl? NaCl initially it is in solid, is a bad conductor because of even though ions is there but cannot move freely. To this what you are adding? Water we are adding. After that what happening? It's becoming like Na plus Cl minus. That's only we are calling as aqueous NaCl. Okay. Now I am taking a container. I am taking, yes, observe very carefully. In this I am taking two electrodes. I am taking. One is connected to positive terminal of the battery, calling as a anode, and another rod is connected to negative terminal of the battery, calling as a cathode, and carries negative charge, carries positive charge. We have to use inert electrode. Otherwise, electrodes is also involving in the chemical reaction. Again, big competition or big confusion will be coming to us. Just we are using these electrodes only for power passing. Just for conductivity purpose we are using. Means inert electrodes we are using. Now, in this what will be there? Na plus particles is there and Cl minus is there. Okay, generally along with this one what will be there? Water is there. In the water generally which particle is there? H plus OH minus. My question. Okay, in the aqueous NaCl, Na plus and Cl minus will be there. Majority water will exist in H2O form or H plus and OH minus form. This is 100% okay, ma. But problem with water. Majority of water will exist in the form of water or ions. Water only. Why? Because water is a weak electrolyte. Means extent of dissociation will be very less. So majority of the H2O will be in the form of H2 only, but not in the form of ions. You must go to that first year salt hydrolysis concept pH. Kw value, there we are discussing all these things. Okay, let it be anyway. We are getting like this here. What particles is there? Just write down. H plus as well as OH minus is also available. Now at anode, observe very carefully. Anode means it is the positively charged rod. Yes, na? There generally which is preferential, oxidation will be favorable. Okay, at anode which particle is coming? Towards anode which particle is coming from the solution? Yes, very good. Cl minus is coming as well as OH minus particles is coming. So that's why I am writing at anode Cl minus is available, OH minus will be available. Okay, now between Cl minus and OH minus competition is going on. Both will not participate in the oxidation because they are different particles. Okay, based on their nature, anyone only more favorable for the oxidation. You have to tell me now. Cl minus is more favorable for the oxidation or OH minus? If you compare actually electrode potential of this one, electrode potential of Cl minus is lower than electrode potential of water or nothing but OH minus. Yes, you can tell. Okay, this is having low electrode potential means is more favorable for the oxidation. More favorable for the oxidation. This is relatively high electrode potential means is favorable for the highly favorable for the reduction. Why this piece is highly favorable for the reduction? Reduction means what? Receiving of electron. Yes, we check it. Now here oxygen is there and chlorine is there. Which is highly electronegative element? Oxygen. 3.5 and this the electronegativity value will be just 3. So more electronegative, more tendency to receive the electron means more tendency for the reduction. More tendency for the reduction having electrode potential value of water will be high. Yes or no? The reduction potential values is directly proportional to reducing current. Okay, that's fine. OH minus is more favorable for the reduction means indirectly what happening? It is less tendency for the oxidation. Automatically it is dominating in the oxidation reaction is becoming like 2Cl minus is gives rise to Cl2 plus 2 electron. Still which is remains in the water, OH minus will be remains in the water. Did you got my point? Yes, now we have to discuss one more thing. It is nothing but at cathode. At cathode. So at cathode means negatively charged rod. There preferentially which is going on, reduction will be going on. Okay, towards cathode which particle is going on? Na plus particle is coming and H plus particle is coming. Both will be there, Na plus and H plus. Generally, at cathode, which electrode potential values is more favorable for the reduction? highly reduction potential values having the elements are more favorable for the reduction at cathode. Both are having same reduction potential? Never. Because one is sodium, one is hydrogen. Now, which is more favorable for the reduction? That's why here reduction potential value of this piece will be high. It is very less tendency for reduction because it is the metal. Metal is more tendency for the oxidation. That's why reduction potential value should be low. So generally what happening at cathode reduction is going on. The reduction nature is directly proportional to reduction potential value. That's why yes, H plus particles is involving in the reduction process. H plus particle means availability will be very less. It is existing in the form of water. So that's why what happening, H2O will receive electrons. Then what we are getting? Anybody? Okay, from H2O what is coming? H plus plus OH minus. That H plus will receive electron becoming like half hydrogen, half mole of hydrogen. Plus which is remaining? OH minus will be remaining. This is only question. So in the water, what remains here? OH minus will be remains. Already which particle is remains? Na plus is already remains. That's why in the reaction mixer, what finally we are getting? Na plus plus OH minus, we are getting a new component NaOH also we are getting. Yes. What is the question under electrolysis of aqueous NaCl? What are the products? What are the products? Cl2 at anode. Which one? Hydrogen gas is at cathode and also NaOH is producing. That's why at a time you are getting three different products. That's why this is the more convenient method. The whole process is calling as a Nelson cell. We are taking in first year, I think you remember, U-shaped holes having material we are taking and we are sending current. Then what happening? Na plus particle will passes through that holes and from down you are introducing steam. Then what happening? Na plus and OH minus will be combined together. Down you are keeping one tub. Then we are collecting NaOH particle. Okay, now I want to explain one more thing. It is nothing but third one, electrolysis. Electrolysis of copper sulfate solution by using copper electrodes. By using copper electrodes. Very simple this is. Okay, copper electrode means what we have to take? We have to take the copper sulfate solution here. Yes, CuSO4 is there. Which electrodes we are using? Copper electrodes only we are using. Means nothing but copper rods we are using. One is connected to the positive terminal of the battery. Another one is negative terminal of the battery. So this is calling as a anode and you know very well positive charge. This is calling as a cathode and negative charge. Already here what is there? Cu plus 2 plus SO4 2 minus is there. Yes. Now you are sending current through copper wires. What happening here? What happening? Two things is going on. Okay, first of all here what will be there? Cu plus 2 and SO4 minus is there. So at anode generally what happening? At anode generally oxidation will be going on. Yes or no? Okay, what happening here? Which particles is undergoing oxidation? Is there any chance for OH minus SO4 2 minus particles is undergoing oxidation? No. Yes, this copper rod whatever you are taking, the copper rod quantity will be gradually decreasing. Upper one will be very thickness, downward will be very thin. Means what happening here? The copper rod is undergoing dissolving into the solution. Means the Cu is becoming like Cu plus 2 plus 2 electron. It is the solid going into aqueous medium. But at cathode what happening? At cathode means is nothing but negatively charged rod. The negatively charged rod means there what happening? Reduction will be going on. Which particles is going on? Reduction. Yes, in the solution we have lot of Cu plus 2 particles. They are undergoing reduction here. So its thickness will be here high. As the time is going on, at a cathode copper rod quantity will be going on increasing. How is becoming Cu plus 2 plus 2 electron? It is actually aqueous medium. We are getting Cu solid. Will form a new layer on the cathode. This is the most convenient method for electro refining. Just I will tell you that point also. This technique only we are using in metallurgy. In metallurgy. For purification of the metals, for purification of metals, we are using this technique in the name of electro refining. Electro refining. Refining is what? Purification. How they are doing? Yes. Okay. First of all, what you have? You prepared one metal in one extraction process. But is it pure metal rod? No. Little bit impurities will be there. Then we have to take the impure metal rod. Impure metal rod we got in the experiment, and we have also pure metal rod we have. Just I will write here. Pure metal rod we already got it. Pure metal rod already we have a reference. Okay, but in the metallurgy we got impure metal rod. Now my question: which rod can be taken as an anode? Which rod can be taken as a cathode? Then it is helpful. Otherwise, our total process will become waste. Yes, for example, you taken copper impure rod and copper pure rod you taken. Okay, in one experiment or in one process, you got copper, that copper is impure copper, but I want to make it as a pure copper. What I should do then? The impure copper rod should be taken as anode. Then what happening? In that impure copper rod, whatever copper particles is there undergoing dissolving. Is there any chance for oxidation of impurities? No. From impure copper rod, all copper particles is undergoing dissolving. Then they are undergoing sticking on. A purified copper rod means finally what happening? From impure copper rod to pure copper rod, the copper particles is undergoing transformation. What is the target of us? That is only target. No, yes, impure metals has to become pure metal. So then, if you want to do like this, it has to be taken as anode and it has to be taken as cathode. Then only what happening? Cu particles or whatever metal particles will be there here undergoing oxidation, here undergoing reduction. Like this will be going on. This whole process is calling as electro refining. Yes, this is a very important thing. Impure metal rod should be taken as anode, a pure metal rod should be taken as cathode. And one more thing, generally in the metallurgy, actually this year they deleted this metallurgy concept, even though we will see at last if any time is there, if any announcement is there, then we can see, otherwise they will. For example, I have gold or silver atom I have. This is right now in impure form. I want to get pure silver, what I should do? Okay, right now these are in which medium? Aqueous medium. To this what I should do? I am adding zinc solid, I am adding. What happening, anybody? You have impure silver ions. Okay, I want to get pure silver, I want to get from the solution. What I should do? For this process, compulsory we have to use zinc is acting as a reducing agent. Reducing agent means itself it is undergoing oxidation. It is a powerful reducing agent. What happening? It will lose electron, that is taken by silver. Then silver is becoming solidified. And zinc is going into aqueous medium. Yes, very simple, no? Initially in the solution we have Ag plus particle, collecting them will be very difficult. To the just add zinc, what happening? Zinc will goes in liquid medium, silver will come settle down. Then we can filter it and we can get the silver. The whole phenomena is possible in case of B block element. But if you take here sodium or potassium or otherwise you can take sodium, magnesium or aluminum. He asked this question in 2020 CET examination. Sodium, magnesium, aluminum you taken. Is it work out with any reducing agent like zinc or something? Will not. Why? For this reduction, these all are in the form of ions. They cannot be, we are not getting metal ions like silver, magnesium, aluminum by using zinc or some other chemicals. Why? These are the first K group element. They are in very bigger size. Themselves they are strongest reducing agent. There is no any other strongest reducing agent than the first K group elements or than the alkali metal. That's why this technique will not work out for this one. But these ions I want to make it as a solids. What I should do? What do I have to do? Or take this one. Yes, whatever metal ions will be there, to that metal ions you have to send current. Then what happening? Undergoing reduction. This why these sodium, magnesium, aluminum ions are extracted or purified by which technique? Electrolysis process, that is specially calling as electrolytic reduction. Electrolytic reduction. This point only asked as the bit. from which metal among the following is purified or extracted by using electrolytic reduction? Which metals? Sodium or magnesium or aluminum. But he given for example iron given. Okay, iron is what happening. Is it possible to electrolysis process? Not requires. Compared with iron, zinc is the strongest reducing agent. That's why if you want to get iron metal from its solution, you have to use zinc metal. But this phenomena will not work out for sodium, magnesium, aluminum. Why? Because they are bigger inside. Themselves they are strongest reducing agent. That's why there is no other strongest element than these three. That's why this is not work out with which one? By using zinc. But this is possible with electrolysis process. That phenomena is calling as electrolytic reduction. Why? Because whatever metal ions is there, they are undergoing a reduction by supplying electricity. That's why we are calling them as electrolytic reduction. Okay. Now we have to see one more thing. Fourth one, electrolysis of copper sulfate solution only, but by using inert electrodes. But same thing we are doing with copper electrodes. Which what happening? Copper deposition will be going on. Copper reduction will be going on from its solution. Anode is dissolving, cathode quantity will be going on, increasing. But the same thing I am doing with inert electrodes. Inert electrode means what happening? You have to check it. See, I am taking here copper sulfate solution only. I am taking. Okay. CuSO4 solution. Into this one you are supplying power, positive electrode and negative electrode. This is acting as a anode and positive charge. This is cathode, negative charge. Okay na? But these electrodes is not copper rod. They are nothing but platinum electrodes, nothing but inert electrodes, or we can use graphite rods also. They are also inert electrodes. They won't respond to any chemical action. What happening now? CuSO4 is becoming like Cu plus 2 plus SO4 2 minus. Already in the water, what will be there? H plus plus OH minus. Now, see carefully at anode. Anode means which charge amount? Positively charged. There always oxidation will be going on. Yes. Now from the solution, which particle moving towards anode? SO4 2 minus is coming and as well as OH minus is coming. So both are undergoing competition here, SO4 2 minus and OH minus. Okay, anybody can tell which particle is more favorable for the oxidation and why? If you give an electrode potential, which is lower electrode potential, that will be more favorable for the oxidation there. We don't know that information, but we can compare just by seeing the species. Here check it. In this piece, only one electronegative element is there. In this sulfur and 4 oxygen, 5 electronegative elements is here. 5 electronegative elements is there. 5 electronegative element means more tendency for which one? Reduction. More tendency for reduction means reduction potential values will be high. But here comparatively only one electronegative element is there. Because of comparatively one electronegative, there is a more tendency for oxidation. More tendency for oxidation means reduction potential value will be low. Yes, we can get it. Out of these two species, which is more favorable for the oxidation at anode? OH minus. How? OH minus cannot be available, but it is available in the form of H2O. Yes, what happening here? H2O will be there. Oxidation means, let's take here 2 moles. Otherwise, we can take, yes, we can take 2 moles. 2 to 4 hydrogens is becoming like 4H plus. And whatever oxygen is there becoming like O2. And how many electrons will be liberating? 4 electrons will be liberating. So, under electrolysis of copper sulfate by using inert electrode at anode, what is happening? Oxygen gas is liberating. Oxygen gas is liberating. No, at cathode, did you got my point now? Yes, at cathode. Cathode means negatively charged. Generally, there reduction will be going on. But which particle is moving towards cathode? H plus particle and as well as Cu plus 2 particle. Yes, you can study. Cu plus 2 is there, H plus is there. Which is more favorable for the reduction? One metal, one non-metal. Yes, metal is electropositive. Electropositive is always having a tendency to lose electron. Then what happening? So it is the low, if you can see the table, low electrode potential will be there. This is highly electrode potential because it is the non-metal. This is the metal. Okay, no, because of high reduction potential is more tendency for reduction. High tendency for reduction or highly reduction. This is the lower for reduction tendency. Now what happening then? Okay, yes, you take this is more favorable for the reduction. You know very well. H plus cannot available, but it is available in the form of H2O. Already you know it. H2O receiving electrons is becoming like which one? H plus receives electron, no? Then what is coming off H2, no? Yes, off H2 plus OH minus. So this is important. Under electrolysis of copper sulfate by using inert electrodes at a cathode, which gas is liberating? Hydrogen gas. Which gas is liberating at anode? Oxygen gas. Are you clear or no? Yes. Which is left in the solution? Which is left in the solution? Yes, you take in copper sulfate solution, you take in platinum rods as the electrodes and you given power supply, something happened, but after some time, what left in the solution? Which ions will be present still in that one? Copper ions will be there and also CSO, but its concentration will be decreasing. SO4 minus ions will be decreasing. Are you clear, all of you? Yes. Now we have to discuss the 4 points. We have to observe very carefully. All of you clear? Yes. Now we are discussing about the laws of electrolysis. Laws of electrolysis is a very important for competitive examination. You observe very carefully. For the laws for the electrolysis, we have 2 laws. Under this first law, I am telling Faraday's first law. Faraday's first law. What is the Faraday's first law? Just I will give you explanation. First of all, I am taking one salt solution. I am taking whatever it is, and in that I am introducing 2 metal rods. I am introducing. I am giving power supply. I am giving this is plus, this is minus. For example, I am sending charge to this solution will be 10 coulombs. Then amount of the metal which is deposited or dissolved is equals to 2 grams. Generally what happening at anode dissolving, at a cathode depositing. So the amount of the metal which is dissolved or deposited should be equal or no? Yes. So means sending charge will be here through battery how much? 10 coulombs. Now I am taking same solution, I am taking same electrodes, I am taking, but I am changing the battery. This is plus, this is minus. Okay, now I am sending a charge is 20 coulombs. Then is there any change in the mass of the metal which is dissolving or depositing? By sending 10 coulombs charge, depositing or dissolving metal will be 2 grams, but I am changing the battery through same solution, means indirectly I am sending 20 coulomb charge I am sending. Then is there any changes in the amount of the metal deposited or dissolved? Yes sir, changes is there or no? Definitely will changes. Why? Because you are supplying more energy, more amount of the chemical reaction will be going on. Then definitely what we are getting around, for example, 4 grams of the metal is undergoing deposition. Means if you take any electrolytic solution, through that solution sending electrical charge is directly proportional to amount of the metal which is undergoing dissolving or depositing. That is only nothing but Faraday's first law. That is what I am writing here. See, in electrolysis, sending a charge through electrolytic solution is directly proportional to amount of the metal, it may undergo dissolving or depositing. Amount of the metal which is deposited or dissolved. Did you got my point? Yes. You are sending 10 coulomb charge, either deposited or dissolved quantity of metal will be just 2 grams. Now we are sending 20 grams from 20 coulombs to the same solution.